So this is part 2, question number 8. So question number 8 by far is the most tricky ones because they only give you certain variable which is only forced being exerted down at an angle on the box, on a friction. And you're looking for mu. So you don't know what mu is, so you're gonna have to understand what's going on. So let me first draw a free body diagram. So you need to know that this is an angle. It's F cosine and this is F sine theta, okay? And this is mg, and that is a normal force acting upon the box. But then you have more forces, so basically how many forces do you have? Let me go ahead. So basically you have 3 different forces, so let's go ahead and look at y direction. So it will be n is equal to F sine plus mg because they are in the same direction putting downwards. That's your normal force. And then you looking at in the x direction. Since the box is not moving at this point, because it says what is the coefficient of the friction between the block and the surface. So basically what it tells you that is a static. So how many forces to the left and how many forces to the right? So on this one, when you look at your multiple choice question, you know that F cosine is equal to that. So basically, so I'm just going to go ahead and show you this one right here. That F cosine is equal to frictional force, and that, okay, I'm going to replace that one later. So I'm just going to go ahead and say F cosine minus F is equal to 0. And I'm going to replace the frictional force. So when I rearrange the equation, right, your frictional force is equal to mu n. And mu n is actually F psi plus mg. So I'm just gonna say replace variable. So F cosine is equal to F because based on this formula it's the same. Mu F psi minus plus mg. So when we're looking for mu, it's gonna I'm gonna have to divide both sides by F psi plus mg. So my answer is F psi plus mg, and those are the only variables that you see on the test. You don't see anything else. So to look at question number 9 and number 10, so I'm just gonna go ahead and use those things together. So I'm just gonna replace this one with m, and this one with small m, and the m is greater than smaller m. So basically what it would do when when you apply the second Newton law of motion, I'm just gonna do both. So I'm just gonna say that this one will go up. So it will be T mg. Okay, these are the 2 different forces. So it will be T minus mg is equal to ma. And I'm gonna go ahead and apply with this bigger m. So the sigma force is equal to mg minus t equal to ma. So what I will do is that I will set this one, so it will be t equal to mg plus ma. Same thing. T is equal to mg minus ma. I put this one on the right and I subtract that from there. So and now I said t equal to t. So it will be smaller mg plus ma is equal to mg minus ma. The combined term. So it will be ma plus ma. So I subtract this side over here or there, and it will be mg minus mg. And I isolate this, put a outside, so that will be m plus m. So I divide this one by both sides. Mg minus mg, m plus m. So isolate this one again. M minus m, g minus m plus m. That's your answer. That's how you figure out the acceleration. So when you apply for question number 9, the answer you should have gotten go ahead, replace for number 9. My big M is equal to 3 minus 2 G. 3 plus 2. So basically, because I'm just gonna replace this one by 10 meter per second square, so that 3 minus 1 is 1 times 10 is 10 divided by 5, so that's 2 meter per second square. That is your acceleration for question number 9.